We've graphed linear inequalities, now we need to graph quadratic inequalities. And we know a quadratic leads to a parabola. And so really this time we're just looking to graph the parabola first and then test points within the parabola or on the outside of the parabola, figure out which points actually work, and then shade in that general area. So let's first look at the fact that we have greater than or equal to. That means that when we graph this parabola, it is going to be made with a solid line. So how do we graph a parabola? The first thing we need to find, if you recall, is find the axis of symmetry. And we do that, it's a vertical line, so it's going to be the equation x equals, and then it's negative b over 2a. So in this case, the opposite of b is going to be a positive 4 divided by 2 times a, which is a half. And 2 times a half is 1, so our axis of symmetry is at 4. So if you want, you can put a little dashed line just to show that we know the parabola is centered around that. We know the vertex is going to be on that axis of symmetry. So to find the vertex, we take 4, we plug it in and see what we get out. And in this case, when you plug in 4, you should get out negative 5. So our vertex is down here at 4, negative 5. We can graph the y-intercept, which is the constant 3. So we have that and we can reflect that over our axis of symmetry. So we know we also have a point over here. If we want to fill in other points, you could plug in other points like 2. When you plug in 2, you get out negative 3. So we could plot that and reflect it. But in general, we can see the shape of our parabola here. Again, we're going to connect this with a solid line. So we just do our best to kind of make that curve there. And we'll do it on the other side as well. And we're going to plug in points to check, are we going to shade inside the parabola or are we going to shade all of this on the outside? So let's pick a point to test. Just as long as it's not actually on the parabola, we can use it. So I love my point 0, 0. I'm going to test that out. So if I plug in 0, we're going to get 0 is greater than or equal to 1/2 times 0 squared minus 4 times 0 plus 3. And all of these times zeros, those cancel. So we basically are left with 0 is greater than or equal to 3. We know that that's not true, which means that 0, 0 is not a solution. So when we're choosing to shade, we're not going to shade out here where 0, 0 is. Instead, we're going to shade inside the parabola here. So if we want to give an example solution, we could say something like the point 2, 1, for instance, right? If I look at 2, 1, that's right here, that's in the shaded region. We could also plug that into our inequality to show that it actually does work. Why don't you pause the video, try this next one, see how it goes, and then come back and check. So I'll just kind of highlight some of the things that we should know from it. We should know the axis of symmetry, right? X equals negative b, so negative 12 over 2 times a. So 2 times negative 2 is negative 4. Negative 12 divided by negative 4 is 3. So our vertex is going to be 3 comma, and when we plug that in, we actually get out 10. So we'd have a point up here at 310. Our y-intercept we can see is at negative 8. That's all the way down here. So that's 3 units to the left, so 3 units to the right. We can reflect that. We could plug in as many other points as we wanted. For instance, if I plug in the point 2, we're going to get out 8. So I could plot 2, 8 and reflect that. If I plugged in 1, I would get out 2. So we could plot 1, 2, and then that's also at 5, 2. So we can see the general outline of our parabola. Looking at our inequality symbol, it's just the greater than symbol. So that means we want to connect this with a dashed line. So I'm going to go ahead and make my curve as best as I can with a dotted or a dashed line. And then it's just a matter of figuring out where to shade. Are we going to shade inside the parabola or out here on the outside? So I'll pick my favorite test point. Since it's not on the parabola, we're allowed to use it as a test point. I plug in 0, 0. So negative 2 times 0 squared plus 12 times 0 minus 8. We're checking if that is greater than our y value, 0. These are going to go away because we're multiplying by 0. So we get negative 8 is greater than 0. Well, that's not true. So that means 0, 0 is not a solution. So we're not going to shade out here where 0, 0 is. Instead, we're going to shade within that quadratic inside here. So an example solution, how about the point 3, 1? That's clearly a point that's in here where we have shaded.